Hi, this is Miss Litton, and this is 7th period review of Chapter 2, Basic Chemistry, and these are my wonderful AP biologists. Say hi.
Hi.
All right. I just finished writing your quiz, and I think it's very fair. I think you have a chance, bless you.
Thank you.
Get a nice strong 10 out of 10 if you are the master of the material. I don't think it's too difficult. I'm not just saying that. I really don't think it is. Also, I just want to tell you, if you want to get started early on it, I have a vote going up until Thursday evening, voice and choice, about the date of your next exam. So if you want to take a look at that, read it. There's pros and cons to either side. I'm not going to change the date unless I have a 60% desire to move. Do you see what I'm saying? So if only 51% say let's move, then it stays as is. And you can read that. It's in Google Classroom. Okay. I'm going to remind you best way to study for your quizzes. Number one, you should be familiar with all the content that I discuss in class. There should be nothing of what I discuss that's questionable to you. Number two, use your textbook. Go to the back of the chapter and do those practice questions. I strongly recommend that you do all the odd ones first and take it like a test. Don't flip back and forth and look at the answers and go, oh, I could see it would be that. Commit on a piece of paper. Commit like you would a quiz. Also, don't give yourself an inordinate amount of time. Think about it like a test setting. Try to recreate the moment, and see how you do under those conditions. Check your answers, and then whatever you missed, go study that part, and then take it again. Take the multiple choice again, and reread those sections. I also strongly recommend that take the time when you are reviewing for Chapter 2, though you know for me it's only going to be a multiple choice test. You know what you're getting. You've already experienced it once before. Take the time to master it well. Take the time to go through and write all your essays. Hi, sweetheart. Write all of your essays. Write, and those of you who looked at, hi, do you need me? No? Okay. Do you need me, sweetheart?
Are you going to be at lunch tomorrow?
What is tomorrow? Thursday. Yes.
Okay, I'll stop by.
Okay. Wait, tomorrow's Wednesday? Yes.
Okay.
I will be here at lunch, but I think I'm not. Oh wait, tomorrow's what's one? Is tomorrow's 135?
Yes.
Yeah, I'll definitely be here at lunch. It's a long day for me.
I'll see you then.
Okay, sounds good. So how many of you were here for the essay review yesterday? Okay. How many of you know it or watched it on YouTube? Okay. So watch it on there. You have multiple sources for essay questions, but I would say it boils down to 3. You have the document that I gave you that's a Google document. That is like the full-on essay, AP-like questions they could ask you, okay? But those questions, when they ask them, they're not really single unit types of questions. They're larger. So it's hard to really answer some of those until you have a few units under your belt. The grid-ins, though, are really good. Those are good examples of the grid-ins that you might have. Second, that would be like number 1. If there's any of those that you could answer, I'd go there first. Number 2, I would go to your textbook, and at the end they have essay-type questions that you can answer at the end of the multiple choice. I would do those. Share them with your neighbors. See what are you getting for that, and compare your answers. Okay. Number 3, not AP caliber questions. They really aren't. They're more like just straight up content based. But could also find their way on your test, and more than likely will, because those are actually fairly easy to grade because they're just straight up, do you know it or you not know it? And there's a PDF in your review folder. So all 3 of those can be sources for essay prep, and I would take advantage of all 3 of those. Okay? General questions on that before I move on? Okay. So as far as your content goes for Chapter 2, we did do the full matter and states of matter, but I think you're going to be pretty comfortable with that. We spent a little time, and you could have a question on how we make atoms happy. Real quickly, let's do the atom story. The atom story. Atoms are made of protons, neutrons, and electrons. I don't know what I was doing there. The protons and the neutrons are in the nucleus, atomic mass. The electrons are in energy levels, 2, 8, 1832. 8, 8 is great octuple. Okay, now listen to me. I do not want you to be sad tomorrow. I can tell you in the 29 years I've been teaching, sometimes students make really silly mistakes on a quiz where I'll say, what's the atomic mass made of? And you would want to tell me? Neutrons. Why did you delay? And you second guessed yourself, right? You know that's an easy cheesy song that I just taught you. I just reviewed it with you, and yet you guys are like, okay. Did you hear you second guess? That's what I'm afraid of that you're gonna do on your quiz. You're gonna be like, well, is it? I don't know. I can't remember. That's like a basic. Remember I gave you the stapler and Scotch tape analogy? Did I give you that analogy? Okay, let's look at this right here. Okay. Oh, I think my Scotch tape's in the back. Oh, we'll just have to use this. Okay? If I ask you, where's the tape and where's the stapler, could you choose the right answer? Yeah, on the left or the right? For you. The left. Oh my God. Okay, so this is in fact the stapler, right? This is in fact a stapler. It is not an application level question. Okay, I'm just asking you, what's stapler? Well, stapler looks like that. I've seen about a lot of them, so I'm gonna go with this stapler, right? I'm not asking you to apply. When I ask you a question like, what does the nucleus consist of? I expect you to go, what? Protons and neutrons. It's a stapler question. Okay, an application level question is I could tell you, how are these two objects, the stapler and the tape, similar? How are they different? What's a way that you could use them? Do you see what I'm saying? You have to know how a stapler functions, and you have to know how tape functions in order to have that discussion. It's not just recognizing it like a content-based question. It's saying both of them do what? Bind things together, you know? So you could say that's how they're similar. How are they different? Okay, you're gonna have to do better. When you write an essay question for me, you can't go one's tape and one's a stapler. Okay? One's an adhesive, right? That holds one object attached to a stable object, where this can hold together two independent objects. This only works if both the objects are small. This one could be used on a large object and a small object, right? So do you see how I'm coming up with differences? I'm differentiating and I'm making similarities. That's an application level question. And what I'm saying to you is, don't miss the stapler questions, okay? Those don't require any thinking. It's just like, that's a stapler. Atomic mass, protons and neutrons. Be comfortable with that and know it and understand it well enough. If you just memorize it only in the way that is I said it in class or on a practice question or in here, if you memorize it in that way, then if I ask the question, it still can be a stapler level question, but if I ask it a little bit differently, you know, then you don't know how to respond to it unless it's asked in the exact same way. So memorization limits you if that's all you're doing, right? But you do have to get the basic facts down. But you want to go to that application level. Writing out your essay questions that are associated with your chapters, that makes you think, forces you to think about big ticket items. And that's a really good idea because as you're approaching, right now you'll have 2 chapters under your belt. The only really essay question I could ask on chapter 1 is probably the scientific method, right? I could also ask you a question about how to do what? Chi-square, right? I could ask you something like that. Those are things that could be a grid in on an AP exam. But if you could be going into, like tomorrow, you're all studied up, so when I introduce Unit 3 to you, you're like, I'm not even worried about 1 and 2's essays because I can jump right in there onto Unit 3. I had somebody come up to me today and ask me a question about an essay on, not Unit 3, Chapter 3. I haven't even talked to you about it yet, okay? But they're already reading that essay, attempting to answer that question, so you can be really confident that when I'm talking tomorrow about Chapter 3, they're going to be like looking for that answer in the words that I say. Do you see what I mean? Now, you were still going to deal with that essay regardless, right? Regardless, you were going to deal with it. Do you see how smart it is to deal with it before I even talk about it? That makes your motivation when I'm talking about Chapter 3, you're like, I am ready. I want to know that. And you are seeking that answer in my discussion. And if you don't get that answer, what are you going to do? You're going to ask that question, right? Raise your game. raise your game to that level, and I'm going to tell you, your life's going to be so much better. Because when it comes time to take that unit exam, you already have stockpiled. You've already documented what you need to know. You've already tried, made attempts at it. Fail faster. Fail a bunch of times when it's just for you. So when you're with me, you don't fail. Do you understand that? When it counts, you don't fail. But if you don't take, and I have had kids who do this, they don't take a single practice, I go, are you answering the questions at the back of the chapter? Well, sometimes. Okay, if you would have failed faster, you would have known there on that practice question in the chapter. If you had done it then, it would have been so much better for you than having your first time that you fail at something be when it's for points. Right? Tell the person next to you before I go a minute further. Tell them next to you, do you need to raise your game, or have you already done that? Are you already elevated? Go ahead. Now, when you raise your game for me, do you see how that can translate into some of your other classes? Because I will tell you, I will have kids who almost see it as a mark of their dedication on the sheer numbers of hours they have spent studying. Do you see what I'm saying? That's not my goal for you. My goal for you is to be very what? With your time. Efficient with your time. I want you to be efficient with your time. It's better if you could spend powerful, short amounts of time than like, I read the book and I memorized everything in chapter 1, but you can't answer a question about it, but you spent a whole bunch of time memorizing it. Okay, so be efficient. Now, do you know how to handle like lithium if I asked you how many protons, neutrons, electrons, and how many electrons are in each energy level?
Yes.
Okay, so tell me how many protons for lithium? 3. How did you know that? This is the atomic number right here, and that's equal to the number of protons. How many electrons? 3. How did you know that? Same number of protons, because they are opposite charges, right? Put those electrons away for me. 2, and then what? 1. Can you tell me anything about lithium knowing it's 2, 1? What can you tell me about lithium?
It wants to gain 7 electrons to be happy.
Okay, it either wants to gain 7 electrons or option number 2, which may be door number 1.
Lose the 1 electron.
Lose the 1 electron, right? Okay, or share, right, with somebody so that it has 2 electrons side by side and then it feels stable, right? Okay, so when you remember, what determines lithium's behavior? The number of what? Valence electrons. It's not the 2 that's determining it, it's the 1. Is it 1 electron? Is it 2 electrons? Because I'll probably just ditch those. If I have 7 or 8 electrons, I'm going to try to find some or share them. So my behavior is determined by the number of valence electrons. How many neutrons do I have?
4.
I have 4. How do you know that? The 7 right here, that's the atomic mass, and it's equal to the number of protons plus neutrons. In this case, this equals 7, so I already know it's 3, so it has to be 3 plus 4 equals 7. Yes? Is that the only type of lithium, one that has 4 neutrons? No. It could have less, it could have more, right? What do you call that when you vary the number of neutrons? Isotopes. Okay? Can lithium only have 3 electrons? No. What do you call it when you vary the number of electrons? Ions. Okay? And if you lose an electron, you're going to become positive, and if you gain, you're going to become negative. Perfect. Okay? Then we started talking about, once we understood an atom and how it works, we talked about that, we looked at the periodic table. And remember what we learned about the periodic table? Remember how it's organized, right? You read it left to right like you would a book, right? Lead row by row, right? What do you call that going across like that? What's that called? Period. Good. You're remembering it, how you're remembering it? Okay? So when you read it left to right, period by period, you're really reading the what? Atomic numbers. It's organized by atomic numbers. But I know what you're saying because we're going across, right? Okay? So it's going 1, 2, 3, 4, 5, 6, 7, 8, right? It's going like this, reading it by atomic number. But when we look at the groups, the vertical, all of these right here, what could you say about the first group? 1 valence electron. Right, 8 or full with 2, right? And then what you were referring to when you talk about the periods going across, that's talking about how much energy, right? When you talk about what energy level you're working out of, right? Are you in if you're in this first one right here, you're in the first energy level, right? The first period. The second one, because we're going to what? 8, 1832. So we're working our way out. So we can tell all of that from the periodic table. Okay, let's answer this question right here. Be your favorite movie character. Be your favorite movie character. Peter Parker. Mulan. All right. Thor. Where are you, Thor? I like you. Wall-E. Magic Mike. Inappropriate. Oh, must be 250. My Fitbit is telling me, want to stroll? Who else is wearing a Fitbit? Where are my Fitbitians? Got yours? Did it ask you want to stroll?
No.
Oh. Do you have yours set to make sure you walk 10 minutes for every hour? All right, here we go. You ready? Are you in? I expect these to be hundies. If you're not engaging in these questions, you're not failing fast. You're just observing. You're watching other people drive before your driver's test. You should be driving. Yes.
Do you want us to spell it out?
Yes. All lowercase. Doesn't it say ALC or all lowercase or something? Did I not do that? In the question, the very first question? I actually don't remember what questions I stuck in right here.
Okay.
I like these.
You don't
I do. What size are you?
have
9.5.
Oh, hi, it's 9.5. That's really big though. I mean, I myself 15. They really are small.
Shoes look different when your foot's bigger.
Especially heels. I forget my true size is bigger, so my foot actually
Fits on it. You don't want to hang in like
Yeah.
the heel up. Okay, 5, 4, commit, 3, 2, 1. Yay! That's 100%. That's 1 for 7th period sport, AP. Oh, I'm a pin. Hang on.
This was confused when you're asking, do you spell it out? 'Cause
Yay, that works. That's 2. Oh.
You know the doors.
Okay, I'm just gonna keep track of this. 2 in a row for AP 7. Okay. Hashtag goals. All right, so chlorine has atomic number 17, and so how many electrons does it have? 17. So how many in the first level? 2. How many in the next level? 8. How many in the next level?
7.
How many people? Probably one person said it, I bet. Yes. Oh, 16 people said this, and 7. Good job. Okay. And next. Oh. How many more electrons would it like?
Wait, 11, because there's...
Okay, we only have 3 shameful people. The rest of you got it going on. Look at you, 14 of you, and 7 of you. Nicely done, 21 of you. I did that math all in my head. Okay, so if it has 7 valence electrons, remember there's 2 ways to make an atom happy. What are they? Tell me. Fill up its shell or what? Not ditch, octet rule. All right, now, it's at 7. What is most likely to happen? It somehow acquires 11 electrons, ditches 7 electrons, or gets 1. Gets 1. Occam's razor, okay? Do what is most logical. It's not going to go get 11 electrons. Check your bio buddy and say, did you get this? Do you need a little shamey?
Yes.
Okay. So then we talked about motivation, clubbing baby seals. I don't know what we did there. Okay, so we talked about that atoms will enter into bonds in order to get happy, and the way they get happy is filling their outermost shell or getting to what? 8, which is the perfect. Okay, so here's what they could do. They could share so that both of them are happy, share their outermost electrons so both are happy. If they share perfectly fair, what's that called? Non-polar covalent. If they share but somebody really borrows it a little more often than the other, it is polar covalent. And polar covalent lends itself towards what kind of bonds? Hydrogen bonds being in the whole system, right? Not in the one molecule, but in the system, the way it's interacting, right? Okay? Polar, non-polar covalent, but if I really want your electrons bad, I might just take them, and when I take it, I'll have a what charge? And you'll have a positive charge, and we're both called ions who can enter into an ionic bond, okay? Then you can have other bonds that we talked about as well, hydrogen bonds. Hydrogen bonds are between 2 entirely different molecules. And what you can say about those 2 different molecules is they must have some sort of what? Could be charged. A polar covalent bond of some sort, right? If they have a polar covalent bond and they have some sort of charge, you can have these 2 different molecules be like, hey, I'm digging your partial positive with my partial negative, okay? And then they will establish that hydrogen bond. By itself, it's weak, but in conjunction with other hydrogen bonds, it's very what? Strong. Good. What is a really good example of a molecule that enters into hydrogen bonds like that? Water. And water will do with anything other water molecules, and that's called what? Cohesion, or with some other polar surface, and that's called adhesion. Good. All right, checking. All right, so we just reviewed ionic and covalent bonds. Feel good about that. Here's a question for you. Hundies, hundies, hundies. Five, 4, 3, 2, come on, commit. Let's go, Yugi. Will Ferrell. Dave Franco. Magic Mike. He's too busy dancing. Wally. The Joker. Okay, I'm done. Oh, Shaka Khan. Okay, atoms of the same element that have the same number of protons but different numbers of neutrons are called isotopes. While molecules that share electrons are called covalent. Okay, we just had 2 of you epically fail and 7 just quit on yourself. Okay, ask your bio buddy, are you okay? Were you lucky? Good? Do you understand? Okay? Then we talked about water molecules. We looked at the hydrogen bonds. We know that the bond right there is a what? Polar covalent. That bond right there is polar covalent. That bond right there, hydrogen bond. Do you see the difference?
Yes.
Okay, within a molecule, they're going to have ionic bonds or polar covalent bonds or non-polar covalent bonds. You only have hydrogen bonds between 2 entirely different molecules, right? Yes? And we see that that plays an important role in the structure of DNA, the structure of proteins, is there interactions due to those hydrogen bonds. We then went through and talked about the properties of water. We said water has a high what? Heat capacity. Okay, so that's why it might take a long time to boil water, right? Because it can hold a lot of energy. But then when we actually talk about boiling and having it what? Evaporate, that's a high heat of vaporization. We appreciate that because of those 2 properties. It mediates the Earth's temperature if we're near water because it can gain and release heat slowly. It's good for our bodies that things don't just start evaporating and turning into a gas in our own blood supply, right? We can handle the heat. It doesn't just evaporate. So, I mean, if you took alcohol, if that was our basis, right? Alcohol at room temperature, it'll start to what? Evaporate. Okay, ours do not. Okay, and then we talked about, I already did that, it could help cool us. We said it was a good solvent. Is it a good solvent for everything on the planet?
No.
What's it a good solvent for? Polar compounds, ionic compounds, it's a good solvent for. Okay, it's not a good solvent for things like fats and lipids, which we'll learn about those mañana. We talked about the significance of it and the success of trees and any tall plants, right? Because water, there's something called the TATC theory. There's tension, adhesion, cohesion, and transpiration that all help water to go up a tall tree. What you needed to know was about adhesion and what? Cohesion. So cohesion is all the water molecules holding hands. Adhesion is they'll stabilize their water column by hydrogen bonding with the walls of the xylem. What motivates them to move up and not just stay stagnant is transpiration. Because the light shines in through the open stomata. As one water molecule evaporates, he pulls on the whole chain all the way down into the roots. And that's what gets water to go up a tree. Not only is that a good thing to get water up there, it's also a way to cool a tree because it's getting cold water from the ground pulled up through the tree. Does that make sense? But then there are a whole bunch of adaptations we'll learn later because you have to balance water loss, right, that you could have with the need for water as you go up. But we'll learn all about that in later. So that's adhesion and cohesion. We learned about words hydrophilic, hydrophobic. Do you understand that all right?
Yes.
We said water could have a high surface tension because one water molecule hangs on to another water molecule, and that's why that water strider indents it. It's not that I would put that one on an essay. We talked about that ice is what? Less dense than liquid water. Yeah, solid water, ice, is less dense than liquid water. Intuitively, we would think a solid would sink. But the reason is, as it cools, those hydrogen bonds become more regimented and equally spaced. Whereas when you're in liquid water, it's, I'm a little close here, I'm a little close here. Becomes more regimented. That space in between molecules decreases the density, and that's why it floats. And the bio-benefit for that, remember, is that it what? Protects the life beneath the ice. Excellent. We talked about, yes, water can ionize into hydrogen ions and hydroxide ions. That happens very rarely. But we do know that when we talk about pH, we're measuring the amount of hydrogen ions in water. So if I put an acid, sulfuric acid, in water, do as you oughta, add acid to water. You put the acid into the water, not the other way around. Okay? That will increase the hydrogen ions. However, when we're doing that, it's a negative logarithmic scale, so actually the pH is lower. And when I say, the pH was 3, no big deal if the pH goes to 2. When the pH goes to 2, you've really changed the hydrogen concentration by what? 10. And if the pH dropped down to 1 from 3, 10 times 10 is 100. Yeah, it's a tenfold difference every single time. And then when you have a base, you have fewer hydrogen ions, you're going to have more hydroxide ions. Okay, like NaOH is a strong base, sodium hydroxide, and it'll add a bunch on there. Okay, now, why are we concerned? Because our cells are sitting in water, and our cells are mostly water, and the pH can change the conformational structure of the proteins that we have in the water that have specific jobs. So we need the pH to be just right. So in our blood, we have things called, starts with a B, buffers. They buffer it. Sometimes in our labs, I'll give you a chemical and I want the pH to stay a specific pH, so I'll put a buffer in there to maintain that pH of 7 or whatever it is I want it to be. Okay, but bicarbonate, we'll be talking about that when we get into circulatory system, helps buffer our blood. Okay, and here was buffers, and here's a question. You're gonna finish right on time? Guys, highly suggested reading and thinking. Did you do it? Remember that? Highly suggested reading and thinking at the top of your group shared notes. At the top of your group shared notes, you have highly suggested reading and thinking. Ask you questions. This particular highly suggested reading and thinking asks you about the interconnections of water, plants, and people. Like, what is the normal pH of water, and why is that? And why is that pH? What generally causes acid rain? What acid rain trends are evident from the EPA data? What is the impact of acid rain on lakes, on forests, on human structures? Where are you going to find the answers to those questions?
In the book.
In the book. And I tell you what page. Assume there is going to be a question from the highly suggested reading and thinking, because that will show up on your quiz. Okay? Don't forget, highly suggested reading and thinking. Look at your bio buddy and smile if you've already thought of it and you already did it, or go if you haven't even remembered it. You committing? 2 questions, finish, so we can move on. 5, 4, 3, 2, delay of game, penalty 5 yards. Terrifying, absolutely terrifying. Which of these ions is important to acid-base balance? Hydrogen, because we just said acid-base measure of hydrogen ions. Did we talk about, 2 of you picked sodium, 2 of you picked chlorine ions as being important in acid-base? Did we even mention them in acid-base relationships? Negatory. Okay, we did not. Right? We just went over that, didn't we? Check with your bio buddy. Say, were you distracted or did you do a good job there? Ask him. You know what would have been really good? And pick up this skill set. You will be surprised how many other questions will help you with questions you have taken earlier. Go back and relook at them. For instance, this one. Which of these best describes the changes that occur when a solution goes from a pH 5 to a pH 8? The hydrogen ion, the hydrogen ion, the hydrogen ion are in every one of your choices. At that point, you should go and go back to the previous question and go, did I pick hydrogen ion? Okay. So when it goes from 5 to 8, is it becoming more acidic or less acidic? Less acidic, which means it's becoming more basic. So if I went from 5 to 6, that would be 10 times less acidic or more basic. And then 6 to 7 is another 10 times, so 10 times 10 is 100. And then to 8 is another 10 times, so that would be 1,000. 1,000 times less acidic or 1,000 times more basic. I'm saying the same thing. So this right here that says the hydrogen ion concentration decreases as the solution goes. Oh, I didn't even ask you from acidic to basic. I didn't even make you do the math, though I could. You could have done it right there, right? Okay, so that's why you would choose A. You would not choose B. The hydrogen ion concentration increases as the solution goes from basic to acidic. Does that answer the question that I asked up here? No, because that's not what it's doing. And then C, the hydrogen ion concentration decreases as the solution goes from basic to acidic. No. Okay, so just read your question carefully to see what was asked, and you know, prepare, do your highly suggested reading and thinking, and you should be good for tomorrow. Do your ed puzzles, right? Okay.
Thank you.
And you're super smart. You're welcome, sweetheart. Go to bed early. Don't stay up late. Have a piece of toast if you get hungry. You know.